Hello children. In this video, we are going to discuss about the chapter Applications of Derivatives Part 1. The topics will be covered in this video are rate of change of the quantities, increasing and decreasing functions. Rate of change of quantities. What is rate of change of quantity? Change of one quantity with respect to the other quantity. That is called the rate of change of the quantities, children. So that means we can say that every year the population is increasing. That means the population is increasing with respect to time t. Okay. Now from one place to the another place you are moving. So by that time the distance. Okay. If I am going from my place to school means the distance from myself to the school will be reducing with respect to the time. Okay. The distance if I consider as x with respect to time it will be changing. Okay. If I blow the balloon, the volume will be increasing, okay, with respect to the radius also. When the radius increase, the volume is increasing. Even we can say the volume with respect to time also. But that means in 1 second some volume it will have, then 2 seconds it will have some volume. Like that it will be increasing. Okay, children. So, like that we can give many examples, children. So, this means we can represent this rate of change of the population with respect to time t as dp by dt. Okay. Then we can represent this the distance, rate of change of the distance with respect to time t as dx by dt. Then rate of change of the volume with respect to the radius. Okay. So that means dv by dr. Then rate of change of the volume with respect to the time t can be represented as dv by dt. Not only this, children, sometimes the surface area of the balloon also. So that means ds by dt. Okay, children, we used to do know well, the function will be given as y in terms of x. So by that time we will say now y equal to some f of x. Then rate of change of y with respect to x we want to say means dy by dx. That is what we are representing as f dash of x. Okay, children, so this is what called rate of change of quantities. Rate of change of one quantity. One quantity is y over here. One quantity is y, other quantity is x. So, rate of change of y with respect to x. Now, here both x and y will be changing with respect to time t also. So, we can say dy by dt and dx by dt. Like this also we can represent the rate of change of the quantity. That means what, children? Y is changing with respect to the time t. X is changing with respect to time t. Like that we can say so many examples, children. You can see here we say no dy by dx, that is a slope. That means the rate of change of the vertical length. Y is actually vertical, children, with respect to the horizontal x. This is y, this is x. Rate of change of vertical length with respect to the horizontal, that is called the slope of the line. Okay, the velocity, rate of change of the displacement with respect to time. Okay, children, we say that the distance is changing, no, that is what the velocity, rate of change of the distance with respect to time. Then acceleration, so the rate of change of the velocity with respect to time is called the acceleration. Okay. The steepness of hillside is the rate of change in its elevation with respect to the linear distance. Okay, children. So, these are the examples for a rate of change of quantities. We see one example. If we blow air into a balloon of a spherical shape at the rate of 1000 centimeter cube per second. Okay, centimeter cube, it says that the volume is changing when you blow air into the balloon. Okay, at what rate the radius of the balloon changes when the radius is 7 centimeters? This was the question. So, volume of the balloon we can write 4 by 3 pi r cube. Okay, but what is given in the question? dv by dt is given as 1000 centimeter cube per second. You may ask one question. Sir, why should we put dv by dt? Because they mentioned 1000 centimeter cube per second. Okay, children, with respect to time, the volume is changing. So, dv by dt is given. Okay. Now, Here they are asking what is the rate of change in the radius of the balloon. Okay, children. So that means what you have to do? Do the differentiation. Okay. So differentiate with respect to t. Why we are differentiating with respect to t? Because it is changing with respect to time only. You can see the second rule here. It's dv by dt. Okay. Then 4 by 3 pi is a constant I write as it is. Then r cube when I differentiate it become 3r square because it is something cube. So 3 something square. But r is something. Why I am telling the word something? Because the r is another variable. T is another variable. So we are differentiating one variable with respect to another variable. That means the rate of change of r with respect to t that has to be represented as dr by dt. Okay, children, like this. Now, dv by dt it is given in the question. We can write it is 1000. Okay. Now, here you can cancel this 3 and 3. Okay. So, now 4 pi. Children, they have given the radius is what? 7. So, we can replace r as 7. So, it is 7 square into this dr by dt. That's all, children. So, we get dr by dt like this. If you do the simplification, you get the answer for dr by dt. But they are asking one more thing also. Also compute the rate at which the surface area changes. Surface area of the sphere is 4 pi r square. So, differentiate now with respect to t. Differentiate with respect to t. It means ds by dt is equal to, here 4 pi as it is a constant. Now r square we are differentiating, it is something square, so 2r. Then r should be differentiated, so dr by dt. Okay, children. So therefore your ds by dt is equal to, what you can write? So 4 pi as it is, 2 into r is 7. We can substitute dr by dt we found, no? I'll just substitute it over here. Okay, we can cancel. So this 4 cancel, this pi cancel, this 1 7 and 7 cancel, children. So now we are getting it is 2000 by 7. You can simplify this. But when you write the answer, what will you write, children? It is centimeter square per second. So here what will you write for this answer after simplification? Centimeter per second. Okay, children. So this is how we should do the sums on rate of change of quantities. Increasing and decreasing functions. Children, we have seen this type of graph in a cricket scoreboard. Run rate, of any team may be in the increasing rate. Okay, children, or else sometime in the beginning it will increase and then it will decrease. Like that also you would have seen. Okay, children. Now, how to say the given function is increasing or decreasing without drawing the graph? That's what we are going to see, children. The first case actually is the increasing function. Children, you can take any two number. They are giving the limit a comma b. In between you can take x1 and x2 in the given interval. Okay, I am taking that x1 less than x2. I am just substituting in the function f of x1. If I get f of x1 less than or equal to f of x2, I can say that function is increasing. Okay, similar way I am taking, but it is just f of x1 less than f of x2. What does it mean, children? Never be equal. Okay, never the f of x1 and f of x2 equal means we can say it is strictly increasing. Okay, children, strictly increasing. That's what. Next, I am taking the same way this x1 less than x2, but I am getting f of x1 greater than f of x2. But if I put equal to means it is just a decreasing function. Okay, but similar case, children, but it won't be equal at all. x1 greater than only f of x2. By this time we can say it is strictly decreasing. Okay, children, you can see the difference of the strictly increasing and increasing function. Here you can see, okay, the stop over here and then it is increasing. Okay, children, but here there won't be any stop, keep on increasing itself. Okay, children, so here also we can see the decreasing and strictly decreasing. Okay, children, so this is what. But some function, they may not have increase and decrease. Okay, so that means even I have drawn, here we cannot say it is a particularly increasing function or particularly decreasing function. You know why? from this limit to this limit, see it is increasing up to this, here it is decreasing from here. Okay children. So like that one. So neither increasing nor decreasing function will be represented in this way. Okay children, that's all. We have to show that the function f of x is equal to 3x plus 17 is strictly increasing on R in this domain. Okay children, I take two numbers. One is x1 less than x2. Okay, so now see that I am going to multiply 3 on both sides. That means 3x1 less than 3x2. And then I am going to add 17 on both sides. That means 3x1 plus 17 less than 3x2 plus 17. So here we know that f of x is 3x plus 17. So f of x1 is nothing but what children? 3x1 plus 17. So we can write this as f of x1 less than f of x2. So I got, you can see here. Okay. So here if x1 less than x2, then it implies we get f of x1 less than f of x2. This implies we can say the function is strictly increasing. Now we will use the derivative to say the given function is increasing or decreasing. Okay children, now see how it is happening. You see one curve like this, I am just drawing. Okay, now see, we know about the tangent to the curve. So I just draw the tangent here. Okay, here. Then in here I am drawing the tangent. Okay children, now see, here if I extend this particular line, it makes some angle theta. I write theta 1. Here if I draw this, extend this one, it makes some angle theta 2. Okay, now we know what is the slope of the line children. It is nothing but tan theta. Here I take this angle theta 1, so tan theta 1. Here the angle is theta 2, I take a tan theta 2. Okay, wow. So now tan theta 1 will be greater than 0. Why children? Because it is acute. But this theta 2, you know, it is obtuse. Okay children, that is what. So here this is lesser than 0. So for increasing, we can see the slope is greater than 0. We know what is slope in the derivative is nothing but f dash of x. Dash of x greater than 0 means it is increasing. F dash of x lesser than 0 means it is decreasing. That is what is happening over here children. Let f be a continuous function on a comma b but closed interval. Okay, differentiable in a open interval. It is increasing when f dash of x is 0. Same way we are telling it is strictly increasing f dash of x greater than 0. What is the difference? Here increasing, here is strictly increasing. See children, this is the tool says that increasing, that means a closed bracket of a comma b. Here this tool says that what a open interval of a comma b. Why it is closed and open? Because at a it may be equal to 0. It has the end, but here no end. It will go till the infinity, but it will not reach b at all. Okay, so if I say 1 comma 2 means, okay, in open interval, it will be up to 2 we will say, but we cannot say that end point. But here, if you write as a closed interval 1 comma 2, we can say the last number is 2. But here, we cannot say the last number is 2 because 2 is not included in the open interval. That is why we say it is strictly increasing in open interval, strictly decreasing in open interval, increasing and decreasing in the closed interval. Do you understand children? That's all. F dash of x will be equal to 0 sometime children. If it is 0 means we cannot say anything about increasing or decreasing. It is just a constant function. There won't be increasing or decreasing. It is neither increasing nor decreasing. Okay children, we do one sum on this. They have given the function f of x is 4x cube minus 6x square minus 72x plus 30. Okay, first job what we have to do is find f dash of x. So that means it is 12x square minus 12x minus 72. Okay, yeah, to get, because they didn't give any value here and all, a comma b, that and all there. No, here they didn't give any value. So we have to get the limit. That's what they are telling. Find the intervals. So for that, what we are going to do is we are equating f dash of x is equal to 0. This is the second idea. Now we'll equate what you get. See that 12 x square minus 12 x minus 72 equal to 0. Here you can see 12 is common, so we can divide by 12. So that means you get x square minus x minus 6. Now you can find, children, it is when you multiply it is minus 6, when you add it is minus 1. That means 3 2s are, here both the term, no, last two terms minus means that the greater number will have minus. So we can get the numbers as x is equal to 3 and x is equal to minus 2. Okay, children, we got the two numbers. So now what we have to do to get the limit? Here they didn't give any limit. So what I'm going to take is here minus infinity to plus infinity I am taking. So the number we are taking as a minus 2 and the 3. Now see, you can have the three limits. One is minus infinity to 2, minus 2, minus 2 to 3 and 3 to infinity. These three limits we are having. Okay, children. Minus infinity to minus 2, then minus 2 to 3 and 3 to infinity. Like that we have taken. So what is f dash of x here? It is nothing but 12x square minus 12x minus 72. So when you take 12 out, what do you get? X square minus x minus 6. So here this can be factorized as 12 into x minus 3 and the x plus 2, like this, children. Now what we have to do, in between minus infinity to minus 2, you can substitute any number in f dash of x. I choose any number, children. Minus infinity to minus 2, I can choose minus 3 itself. I choose. Okay. So therefore f dash of minus 3. See what is happening, children. In this quadratic equation itself, we can substitute, but the squaring and then addition, subtraction and all done. But here it's simple, children. If you write as a factor, immediately you can get the sign. So 12 into minus 3 minus 3, here minus 3 plus 2. Now you can say that it is negative. Here this is also negative. Now the product will give you positive. That means greater than 0. We can say that f dash of x greater than 0. Therefore f is increasing on this limit. Okay. So I will be using the closed interval, children. It is minus infinity to minus 2. But I say the word increasing. Okay. If I say the word strictly increasing, means f is strictly increasing on minus infinity to minus 2. See here I put the open interval. Okay, children. Now another limit I take, it is minus 2 to 3. When minus 2 to 3, no, I just take that x is equal to 0. It's better for me, because minus 2 to 3 confirm 0 is there. Now I'll find the f dash of 0. So I'll substitute here 12 bracket 0 minus 3, then 0 plus 2. Now see, children, this is negative, this is positive. You will get the product is negative only. It is greater than 0. So this implies f dash of x is greater than 0. Therefore, we can say f is decreasing on which interval, children? I just put a closed interval, minus 2 to 3, because I say the word only decreasing. If I say that f is strictly decreasing on open interval, we have to put. That's all, children. This is a difference. Okay. Next to the last limit, it is 3 to infinity. Okay. I take any number, children. Here also, let x is equal to some 4, because easy number, small number we have to choose. That's all. Now f dash of 4 I am choosing. That means 12 bracket 4 minus 3, then 4 plus 2. See, children, am I doing any calculation here? No calculation at all. Just checking the sign. It is positive. This also positive. It is equal to, that also what? Positive only, because positive into positive greater than 0, children. I can say that this f is increasing on this closed interval. I am using 3 to infinity. For infinity and all, I am just using the open interval only, because I don't know what it is. But closed means it is included. Okay. So here f is strictly increasing on open interval I put. That's all. So the given function is increasing in minus infinity to minus 2 and 3 to infinity, decreasing on minus 2 to 3. Okay. So this is how we finish the increasing decreasing function. We will see the next part in the next video. Thank you, children.